Hello, this is Tirtha. So for this project we used aluminium wires, and that was a translation of this aluminium sheet metal structure into a wireframe structure. So here what we did is aluminium wires were used to duplicate exact same replica of the aluminium sheet ones, and the main properties of aluminium are it's highly ductile and flexible, can be bent into whatever shape needed, and it gives a perceivable interior, and you can see through. So the model gives you an idea of what happens inside and within. So now we'll be demonstrating how to cut. So the major equipment used for this are a wire cutter and a plier, nose plier. So the wire cutter has basically two phases, sides. So one is the flat one and the other one is the edgy one, sharp one. So it's preferable to use the flat one. So it's easy to cut. So when you cut like this, here you get a flat edge, and this becomes easy to stick onto another surface which is also flat. But then when you cut on the angular surface, you should remember that we flatten it again. And the main adhesive used for this purpose is cyanoacrylate. So cyanoacrylate can easily be stuck to another surface edge to edge, and it takes just 2-3 seconds for drying.
Hi, my name is Arnav. As Tithai said about the purpose of this project to bring precision, and because the model is transparent and we can see what's happening inside. So if you can see this model, so there are certain critical points here. So while making aluminium models, we get the advantage of pasting the whole edge to the different surface, but here we don't get that advantage. So here everything is on points. The critical points are being located, figure out, and then we join the things. So in this case, suppose there is this model here, we have the circular cutout. So in this kind of models, we get the opportunity to have a proper puncture, but here we don't get that opportunity. So we have to add some additional members onto it so that the whole circle gives the feeling of that puncture. In this exercise, we have different type of aluminum wires. Some are thick like 2 mm and quite they are very flexible, and there are some MS wire as well which is being used in construction purpose. That is also a bit flexible, and we have this aluminum wire which is sturdy, and it's difficult to work on sometimes because it's pointed, and we have to take care of the pointed part by blunting it with the sandpaper sometimes. Okay. The challenges to this project is bending of the wire is a bit difficult. So sometimes it hurts the fingers, so we have to be really careful about doing that. Here we have to always see that in this model we can see that a lot of wires have been added. So we have to reach that sweet spot where the whole model is more visible rather than the additional members. So this is the kind of model which is overdone, but we have an example of this is the finest model which has less of additional members, and the whole model can be seen properly. There is also another example of a model. Here instead of a puncture, there is a chance of creating something new. This is to give a sense of circular puncture. So this is a kind of creativity that we can come up with in wireframe models. So in this kind of exercise, we also get to learn about different type of knots. A lot of students have just created some knots here with the finer wire to the thicker wire, and some have used Febiquick or the cyanoacrylic thing and glue to fix the joints. Like this is a cyanoacrylic fixing model, and these are like joints. But if the bending and the joints are not proper, then some students might have end up with this kind of models because of improper joints. Now in the wireframe model, the challenge is that it's transparent. We have to be really very honest about all the fixing points, and if those joints are not clear and the bendings are not clear, there is a visual noise about this thing. So that's the beauty of this model, that we have to be very honest and we have to be very precise.